Not a very good. I like your attitude, Eric. Not sure I believe it.
Do you have it correct?
Well,
Otherwise,
well, I'm scrambling as well.
It's all right. I totally need lots of help because I asked somebody to have all the slides ready and they're not here and they're not ready and they're not out. Because I just came from a Korean standards breakfast meeting.
Oh. Well, you know, it's free help, right? That I was trying to get, so you can't twist that. Stephanie, save the day. Thank you. Hi. You just put that? Okay, put you as far. All right, no problem. I'll do it on the fly. I'm totally unprepared this morning. Thank you.
And so, Richard, thank you so much. If I can, like, I was hoping to just be able to switch over to my laptop for some pictures. Did I show you the pictures I had ready? You'd be proud. Oh, you saw them already. Oh, you got to see this picture. I'll try to use this.
Yeah. Well, I have no idea. And the internet is also with me.
I'm just giving you a couple of minutes. I'm sorry, I was coming from another meeting and I thought somebody would have the slides ready for me. And so slight delay. And I'm having trouble with the network. So hopefully. I may have to have presenters. I hate to ask people to like get off their laptop for a couple minutes so I could. My connection sucks. I can't download anything right now.
No problem.
I'm getting this site can't be reached all of a sudden.
Changing browsers.
EDF doesn't work either though, so I think it's network.
Point.
Oh, sorry. So I don't recommend. Yeah. No rush. Yeah. I don't care.
Yeah, that's actually.
It looks like that.
Yes, that's a good idea.
I seriously need to. So my network isn't working. I have a good slide deck,
So you can't detect.
but if you could run all the other slides and you're gonna set up everything, that would be amazing. Thank you. All right, great. So I can get started in a couple minutes as soon as. Very good. Sorry for my difficulties. It was just I was running from one thing to the next this morning. Right. Yeah, I should plug into.
Yeah, I have 0 battery, so hopefully it has some before you need my laptop.
So as you probably have noticed this week, Steven's not here. He wasn't able to make it last minute. So thanks for everyone who's been able to help. This is the Security Area Advisory Group meeting. If you intend to be someplace else, now's your chance. And we'll get started. So here is the note well. And our agenda today, there was a little agenda bashing. The effect of ubiquitous encryption is going to get bumped down to later in the list of presentations. Any other agenda bashing? All right, great. So now we're going to run through working groups. And last I checked, there was a whole slew of them that did not send in their report. So when I call a working group that hasn't sent the report, usually we have much more, so that's why I'm explaining this. You'll need to get up to the mic and explain, give a short summary of what happened in that working group. So ACE, I don't think we got any summary from ACE yet. That's okay. A report can get sent, so if someone wants to give a little overview for ACE and what's going to happen, that would be great. Yeah, so we do typically have people send reports in before meetings as well, just with the status of what might occur. Acme? All right, thank you. Cozy did not meet, and they're probably going to close today, so I won't make them get up. Their work is completed. They've done a great job. There's just one tiny little piece to get solved in a draft that should wrap up quick. Curdle, I know they meet later in the week, but oh, I thought Ben was getting up to say something.
Do I have to say more than we meet Friday? We have a bunch of drafts, a couple in last call. It's progressing. They're all short, simple to understand even if you don't know the math, which I don't.
Dane, I got a report to SAG, I believe.
I can do that quickly. Yeah, so Dane's not meeting this time. We have an S-MIME draft, which is going through working group last call again. If anybody would be willing to review it, we'd really, really, really appreciate it. The whole putting email addresses in the DNS isn't really in scope for this working group last call because we did that in an RFC. And so, this does the same thing as that. And then we may have one other working group business piece. We'll find out early next year if that's going to progress. Other than that, we might be done. That was Dane.
Okay, dots. Thank you. HTTP auth. They should be closing within a few days. I won't make them get up. So thank you for your work in that working group as well. I2 and SF. I don't think I saw a report for them. No. Can somebody report for I2 and SF, please? Any participants? I guess the chairs aren't in the room.
Bob Moskowitz, I was there. We met. They're making headway in the drafts and the Yang modeling and the for the various messaging and the structures. So there's a few documents adopted by the work group. Progress being made, but a lot more to go.
Thank you. IPSecMe, I think we have a report. Thank you. Kitten, we received a report. Thank you. Lamps, I think we got a no report for lamps. I don't think they've met yet, but does someone want to give a?
Since Russ doesn't seem to be coming up, there's 3 drafts. One is gone into last call. The other 2 are expected to go into last call mid of December, early January.
Thank you. Mile, I don't think I've seen a report from Mile either. They have
Friday afternoon.
Friday afternoon. Does anyone want to talk about the drafts? There's a bunch going into last call soon with transports. And I know there's interest from other working groups too in some of those drafts because it's data formats. Go ahead.
So Mile has not met. There is the data model in Auth 48. There is Rolly being talked about, a couple of the transport documents, and I think the implementation report's about to be pushed out.
Thank you. OAuth. I don't think we got a report for OAuth, and they did meet twice. And Hannes is gone, so he's off the hook. Anyone else want to get up for OAuth? There's got to be a few OAuth people in the room.
Mike Jones, Microsoft. We discussed the status of a number of current drafts, plus Torsten Latterstad wrote a new draft that's an intended BCP on OAuth security best practices, which deployments have shown the need for. That was, I believe, going to be adopted as a working group document.
Thank you. OpenPGP Sense, there's SACM. Thank you. Sec events. Thank you. TLS was sent. I remember seeing that one. Tokebind. I don't think. Oh, okay. Thank you. Trans was sent. And now related working groups. All right. So I know I saw one for Anima. Would anyone from the related working groups want to get up and, so Anima, Dime. Dime did not meet this time. Dispatch. Anyone want to give an overview for dispatch? DMARC. A little bit of a hot topic this week. All right. Deprive.
Deprive hasn't met yet. Meeting tomorrow. We've finished our phase 1 work, and we'll be having a BOF or a BOF style discussion in the meeting on what we're going to be doing with the phase 2 work. I think that's we have some documents which are progressing.
All right, great. Thank you. HTTP Biz. Quick. There has to be someone in the room that went to that.
They met, decided who was editing the documents. There wasn't a whole lot of discussion of detail.
Thanks, Ted.
Come on, we got the Indianness settled. It was like
That's
a big
true.
thing,
We did
right?
settle Indianness.
We're network byte order again, man. Come on.
Thank you both. NetConf. Perk.
So PerkNet, we're trying to wrap up our kind of media crypto layer stuff. We've got some extensions to TLS related to key transfer and some tweaks to SRT, a new protection profile for SRTP that does some funny crypto stuff. So review would be welcome. We should have last calls coming up on those soon.
Thank you, Richard. Radext.
So almost all of the drafts are either IESG or RC at the moment. We're basically getting ready to rev the TLS documents.
Thank you. TCP Inc.
All right, Kyle Rose. So we haven't met yet. We're meeting tomorrow at 9:30. We're hoping to get to working group last call on the 2 main documents shortly after the meeting. The other issue that I think we're going to talk about is some of the crypto questions that I posed to CFRG, but we're going to hold that for later in the meeting. So hopefully TLS will be done early and some folks from there can come to TCP Inc.
Thank you. And Utah.
Utah haven't met this time. Basically, chair's waiting update for 4 main documents for MTA, opportunistic security, and other things. So it's a bit slow, but I think there is progress.
Thanks, Alexi. So IRTF, CFRG. Thank you. IRTF open. All right. PrivSec program for the IAB.
Not on PrivSec. Oh, actually, Ted, please.
It actually meets tomorrow morning, so it has not yet met. It will be talking about the web PKI document and the mitigations draft, as well as the metadata insertion, although my understanding from Stephen is that the metadata insertion draft will actually proceed as an IETF document that he will sponsor rather than staying in the IB.
Thank you. And then W3C?
Thanks. Sent an update. Lots of work going on in W3C's web application security group, web authentication, web payments, and there's a hardware-based secure services community group that's going through the W3C equivalent phase of BOF and consideration for working groups. So people interested in any of that can follow the links.
Thank you. IEEE?
I can at least talk to 802.1 work, which is coming on, which is particularly going to may affect here. 802.1 AR addendum, which is the device certificate, device identity, which is used in Anima and in NetConf. That is being changed to a revision, and that's adding the SHA 384 and P384 curves to support it within device identity, and that is pretty much out of the task group last call, going on to the work group. So I can't really say when it'll go on a sponsor ballot, but maybe early 2017. The Ethernet encryption 802.1 AE addendum is, again, that's adding the support for the 250 AS256. So that's moving along. And just a side note that Yang data modeling for 802.1x is revealing some interesting different ways of looking at 802.1x, which that may have implications to some uses of that. Hard to say what impact that'll have on IETF.
Thank you. All right, so we didn't have any security BOFs. Margaret, did you want to talk about Banana now?
Want me just to take it without slides?
Yes, please. Just a quick, if there's more time at open mic, we can.
Yeah.
Go
There's
through.
a BOF going to be held tomorrow at 1:30. I think it's in Grand Ballroom. No, it's in Park Ballroom 1, I think, called the Banana BOF. It's bandwidth aggregation for network access. Basically, the problem for the BOF is that you have non-multi-access aware hosts on a home or small office network, likely, that have more than one point of attachment to the internet. When you normally use this sort of host to do, say, a big data download, you only end up using one of your links to the internet, because whichever gateway you pick is the one that you end up using. But we want to figure out how to do bandwidth aggregation across multiple links to the internet. There are a number of solutions being discussed in this space, including a tunneling solution and using an MPTCP proxy. There are a bunch of security concerns. They differ based on what solution and what scenario. And the solutions, as I said, are different technologies. The scenarios are, do we just split the traffic and reconverge in the operator network, assuming the links are from the same operator? Do we do it somewhere in the internet, assuming there's some sort of bandwidth aggregation service provider? Or do we do it on the other edge? And the security varies a lot there, but various security issues are a concern about man-in-the-middle attacks, concerning about being able to redirect your traffic to an attacker. And we would love to get some security people in the room to help make sure we know what those issues are. Thank you.
You said tomorrow. It's
I'm
today.
sorry, it's today at 1:30. Sorry.
And I forgot one very important thing. Can I have a Jabber scribe and somebody to take minutes for the rest of the meeting? Oh, thank you. All right, great. Minutes. Should be pretty easy from here on out. I'll have to go back and do the ones from the video. Thank you. All right, presentation. So we have Professor Yum. First up, on an overview of information security relevant work in Korea. So if you want to, oh, am I from? Okay, yes. So if you can come up now, and I don't think we have your slides, so we'll have to plug you in directly. Thank you.
I'll just move. That'll work.
So you could either sit here or stand there to give the talk.
You want to sit? You want to stand?
Thank you.
So 30 minutes, 20 minutes, 20 minutes.
30 minutes.
30 minutes. Good morning. My name is Hung Lim. I'm working for Suncheon University as a professor. So I will talk about the information security relevance work in Korea. So I would like to thank for all of you for inviting me to make a presentation on these topics. Since I believe that this is Korea, so this is the advantage of the host, I believe. Yes. So my presentation consists of three parts. First one is a recent cybersecurity landscapes, and the second one is a information security governance and best practice, and third one is a some information security relevance work in Korea. So I will present one by one. So actually, first, if you look at this slide, it's a cyber security landscape in Korea. So we have suffered many DDoS attacks, and also we have suffered the APT, advanced persistent threats also, and we have suffered a disruptive attacks. Target would be a internet service provider and also some telecom operators, including KT. And we have suffered several personal data leakage instances. And we have unique national identification number that is a residence registration number. So this is target of the this instance. And this is a typical scenario we have suffered in Korea. So actually attackers forms a botnet consists of the more than 10,000 what impacted computers in the center, and they use this but impacted computer to make a DDoS attack to the several websites, including government sites and also some internet service provider sites. So that is the main targets. So, and then we have suffered a several cyber security instance. For example, on July 7th, 2009, 7/7 cyber DDoS attack has happened, and then target includes more than 40 websites. We believe that this is first massive DDoS attack in Korea. So we, after these sessions, some security measures are has been strengthened. And then second one is on March 4th, 2011, we call 3-4 cyber security attacks. Also, this is a DDoS attack, is a nationwide DDoS attack, including target includes a Korean blouse, and also government ministries website and major financial organization and ICT service providers. And this is a typical, recently attackers utilize vulnerabilities of the infrastructure, security infrastructure itself, that is a patch management system. So attacker uses a vulnerabilities of the patch management systems, and then some malwares are impacted into a organizations, victims organizations computers. So that is we believe that this is a kind of the APT, advanced persistent threats. So this is we believe the first massive disaster APT attacks happens on March 20, 2013. So we call 320 cyber attacks. Actually, 3 major banks and 3 major Korean broadcast company, including KBS and the MBC, are targeted, and also they utilize a APT, advanced persistent attack, and they utilize a malwares to disrupt a infrastructure, and also they utilize a patch management systems actually operated in victims' networks. And so the objective of this attack is to disorder national, social, and economic systems in Korea. So we suspect the source of this attack comes from North Korea. And this is a information security governance in Korea, and KISA. So KISA is a Korea Internet Security Agencies. So active roles to play in protecting Korean cyberspace. Actually, we have Korean presidential office here. So cyberspace has been divided into 3 parts: public cyberspace, private cyberspace, and defense. So all relevant government ministry has their unique roles to defend their own. Actually, to defend private sectors, MSIP, Ministry of the Science, ICT, and Future Planning is responsible for. Under the Minister MSIP, there is a KISA, Korea Internet Security Agency, actually has a unique roles in defending Korean cyberspace from attacks. Actually, we have some rules. So that rules ask some private sector to provide some traffic informations, static informations to coordinate a massive DDoS attack, network level DDoS attack. So so IP service providers and smartphone users and those portals, commercial companies are cooperating to prevent these cyber attacks. And actually, let me briefly introduce KISA. KISA was established to create a safe environment. Actually, in 2009, there was a former KISA organizations, but reorganized on 2009 July. The main objective is to 3 roles. Among them, first role is very important, is that to prevent a cyberspace, private cyberspace, providing a guidelines and providing a operational services to the cooperated with the other relevant internet service providers and also other stakeholders in Korea. We have rules that is based on the Act on Promotion of the Information and Communication Network Utilization and Information Protection, etc. So actually, all cybersecurity response actions or works will be coordinated by the Korean President's Office and Center. There is a KISA, Korea Internet Security Center, will coordinate with by sharing information with relevant government organization and with sharing information with ISP. We have 3 major internet service providers: KT, SK Broadband, and LG U+. And also we have international relationships, for example, FIRST and APSOT and Microsoft itself. And we have local antivirus companies, so we will cooperate and sharing information to prevent our space. And KISAS has 3 divisions and 1 centers and 11 teams, and number of participants work is around 160. So major role. Actually, this is part of the KISA. So KISA has a Korea Internet Security Center. So Korea's internet sector has a rules on internet instance response and internet instance analysis and infrastructure protection and cybersecurity training and certification. So that is a major rules under of the Korea Internet Security Centers. And activities, we operate a 24/7 hours monitoring services and for preventing monitoring, and we have some detection measures such as a malware and DDoS attacks and finding a vulnerability of the software and applications. We have analyze tools to analyze malwares collected by and shared by organizations, relevant organizations. We have a response recovery teams, and also we have cooperations with other international cyber security relevance organizations, example, a SOT. And our goal is to reach the global corporations. So we have a SOT organization, and we establish a cyber threat intelligence networks, including a local antivirus company as also global company like this. And we establish a cyber alliance for multi-mutual programs called CAMP. So member of this alliance includes ministries and government bodies and non-profit organizations. Currently, 47 organizations from 35 countries. Actually, I would like to briefly introduce some best practice. Actually, we have as you know, currently we have a serious issues, so-called drive-by download attacks. So we need to have some websites having a malwares which can be used as a drive-by download. So we have some searching functions in KISA. So we call malicious code finders, and then check more than millions websites for infection of the malwares. And then after we find that malicious code, we inform administrator of the website to remove the malware. That is the main operations. And then we have a online disinfection systems. So if some users has some malwares actually in their personal computers, and then we visit a KISA's websites, and then we use KISA provide some very specialized antivirus programs that only curing that malwares. So this is we call online malware disinfection systems, which is operated by the KISA. And we also have a DDoS shelter systems. Actually, we have two types of the measures for DDoS attacks. First one is a network level DDoS systems, and also second one is a kind of the host level. So KISA provide a DDoS shelter systems for only for small and medium companies, not include a large companies. So that is a main objective. So KISA provide the kind of the DDoS shelter systems to the small and medium, because small and medium enterprise has a limited capability to prevent a DDoS attack. That is main objectives. And also we have a bot response systems. We call DDoS sync systems. So if some computers are actually impacted by malwares and would like to connect to command and control servers in the internet. So actually they would like to ask a IP address of the DNS bot impacted command and control servers. So in that case is that communication is directed to the KISA's HoneyNet systems to analyze the DDoS attack. So that is a main object. So we operate a DDoS DNS sync systems to prevent a bot impacted computers. And as I said, there is several measures to DDoS attack. First one is a network level DDoS attack prevention system, and second one is a host level, and third one is to remove malwares in the user's computer. That is 3 levels. So we currently operate 3 level measures for preventing a DDoS attack and responding DDoS attacks. And we also have a online bot impact checking systems. So this is if you visit some KISA's website and then check if their user's computer is impacted botnet or not. So if that computer is impacted, in the cases some specialized antivirus program will be downloaded to the users' computers and then removed the malwares. That is the main operation. And then international security standard activities. Actually, we have TTA, telecommunication standard organization in Korea. So actually MSIP is sponsoring TTA activities. So TTA developed a TTA standard in the ICT area, including information security. So there is one technical command, TC5, is responsible for the developing TTA standard in the area of information security. So there are several contributors, organizations to submitting a contributions to make a. Actually, we have a good relationship with IETF, so we sometimes use a IETF RFC documents to make a TTA standard. And this is an organization stage structure of TTA. So we have 6 technical committee, technical committee 2 on telecommunication, technical 4 ICT convergence, and technical 5 information security, and technical 6 software content, and technical A broadcasting, technical 9 radio, mobile communications. So TC5 is responsible for developing a TTA standard that is a domestic standard in the area of the ICTs. TC5 is responsible for the developing a TTA standard in the area of security, information security. So there are 5 project groups under the TC5. So this is 5 TC5. So PG, we call PG 501. PG means the project group. So project group 501 on information security infrastructure, and project group 502 personal information protection and identity management, and PG PG503, cybersecurity, and PG504, application security and evaluation and assessment, and PG505 is on biometrics. So by using these 5 projects, we are now developing a information security relevance TTA standard. Actually, we have some committee for international standard organization. For example, Korea Mirror Committee SG17. Actually, I'm chair of this Mirror Committee chair, and we have a Korea SC27 JTC1 committee, and we also have a SC37 committee. So actually, the main role of this Mirror Committee is submit a contribution to the relevant standard developer organization, including IETF Study Group 17 and the JTC1 SC27 and also JTC1 SC37. So, and then if you look at this committee, actually Korea IETF Study Group 17 Mirror Committee organized by, coordinated by the TTA and RRA is government organizations, and actually all contributions and to the IETF Study Group 17 are coordinated with this Mirror Committee. And also we have Korea SC27 Mirror Committee, and same notes, and then different organizations, so JTC1, SC27. So, and we have Korea Privacy Security Forum. It was established in 2016, this May, so sponsored by TTA and MSIP. So, and so actually this forum is supported by many government organizations, and also our forum is objective is to contribute to the work for the international standardization, including IETF and the ITO and JTC1. Thank you. That's all. Any questions?
Thank you, Professor Yum. We do have at least another 5 minutes if folks do have questions. All right. So I guess thank you very much.
Okay, thank you.
And let's see, the next talk is on crypto conditions. Adrian Hopel. Hopefully I said that correctly.
Crypto conditions.
Yep, Warren's pulling them up.
Do you want the cookie thing? Want the clicker? And 2 minutes.
Right, hi. So myself and some colleagues had a BOF in Berlin on the Interledger protocol. I think some people here attended that. Crypto conditions is a piece of that work that we developed. It's an essential component of the Interledger work. Crypto conditions is basically a standard for composing signatures out of composable pieces. There's a bunch of features here which were requirements for Interledger, but we think that the scheme is useful beyond what we use it for in Interledger protocol. It's intended to be very minimal, very straightforward to use, where we use existing crypto primitives like existing signature schemes. We specify exactly which parameters to use. As an example, it's composable, so I'll get into details of how that works. It's designed to be extensible, so we've defined a few
types to start with, but you can, the encoding scheme allows that to expand. And it's quite efficient. So you'll see the conditions themselves are all a relatively small size because we use Merkle circuits to produce a fingerprint for the whole composed signature. Very quickly, just 2 slides on the background. So the way Interledger protocol works is it uses these conditions as effectively a distributed trigger. You have a bunch of ledgers out there which have a transaction queued, waiting to be executed, and all of those transactions are queued pending fulfillment of a specific condition. And either that condition is fulfilled or it times out and the transaction executes or rolls back. So that's the sort of high-level view of what we needed out of crypto conditions. In the blockchain space, the word smart contract is used a lot. So really, I guess what we were looking for was a smart contract, but effectively we needed a way to describe to a ledger some condition that needed to be fulfilled for that ledger to execute the transaction. This is a financial transaction when we're talking about ledgers, but really it could be any distributed system that has some sort of prepare and commit, two-phase commit protocol. So we looked at simple signatures, straightforward existing signature schemes. They didn't really meet all of the requirements we needed because we needed the ability to do things like multi-sig. Multi-sig itself, none of the standards that exist for defining multi-sig really footed the bill. And then right on the other end of the spectrum, we could have gone for a full sort of Turing complete programming language like other sort of smart contract systems like Ethereum have done, where you can actually provide a piece of code that executes and comes out with a, true or false, this is fulfilled or not. We ended up settling for something in the middle, and that's because Interledger has some quite specific feature requirements. Those 2 gray circles are ledgers in this diagram, and those are conditions above them. And what's important when you're setting up a financial transaction in this way is that the outcome is both deterministic across all ledgers and predictable up front. So a ledger needs to know when it receives the condition that it will be able to evaluate the fulfillment when the fulfillment comes. So when it gets the trigger to release the transaction, it doesn't help if some ledgers interpret that trigger and other ledgers see the trigger and actually can't interpret it because it's too big, or it uses a underlying cryptographic algorithm they don't understand or something like that. So we needed some metadata attached to the condition that describes some of those things. And when I get into the format, I'll explain how we've done that. So we settle on something somewhere in the middle there. It's a little bit more than a multi-sig. So as I said, it has some additional features, but it's not a full programming language because we needed that absolute deterministic nature, even if the systems interpreting the conditions run on completely different stacks. And we rely here on the deterministic nature of the underlying crypto primitives, so signature and hash algorithms. What we do is we define a bunch of types, so different types that are used in the system. Either basic signatures, so you evaluate them according to a normal signature scheme algorithm. I have a public key, I have a signature, I have a message. Is the signature valid, yes or no? And then we have types which are thresholds. So this type has a number, let's say 2, and it contains 3 signatures, and if 2 of those 3 are valid, then the outcome is true, or then the threshold condition is fulfilled. But in order to make this a little bit more flexible, we basically took the simple signatures and hashes and we packaged them in the same way as the threshold types. So the API or the encoding format looks the same for all of them, and that allows you to embed compound signatures within compound signatures. So you can compose quite a complex tree out of these pieces. What you end up with is the ability to build something like that, effectively a Boolean threshold circuit where each of the logic gates is a crypto condition or a signature, a hash, something like that. So you can see in this instance, the circuit is the result of 2 of the 3 signatures at the top. Let's assume Chandra, Lena, and Bob each are providing a signature. If 2 out of those 3 is provided, then that gate is true, in which case the overall signature is true because the gate below requires either Milli or the compound one above. So you can see how then you can build up some quite interesting scenarios. An example is this one where, for example, you have 3 bank employees. 2 of the 3 need to provide a key to fulfill a condition, or there's some sort of security override that could also provide a key. Part of the rationale for bringing this to IETF is that there is an existing call for standardization in the space. Christopher Allen and Shannon Appelklein are involved in an identity work specifically at the UN and the UN's ID 2020 initiative, where they wrote a paper called Smart Signatures, calling for a standardization around something like this, effectively a signature scheme that was a little smarter than existing schemes, but presented a similar API, so a similar algorithm for validation. Give me a key, a publicly shareable piece, give me a message, and then validate the signature, true or false. The draft that exists today is in its second rev. There is a new rev, which is a fairly significant upgrade on this one. I'm afraid it wasn't ready in time to share. Mostly just changes to explanations and a lot more descriptive language around why we've done this work and how you might use it in other use cases. Specifically, what the draft describes is the formats. So we've used ASN1 to describe the encoding. Canonical encoding is binary. We've gone for OER as the encoding rules. We thought it was a better bet than DR or BER or any of the others for a variety of reasons. One of the big things that is changing or that is proposed to change is that rather than having an enumerated set of types, there will still be an IONA list of types with numbers, but it won't be, the type will just be a bit string. And rather than the feature bit mask, there will be a subtypes bit mask, bit map actually, and it's not a bit mask, it's a bit map. So I apologize for the confusion there. And what that is for the compound. Why that's important for the compound types. You need to understand from the condition what are the types of any conditions that may be embedded in there, and that's for that upfront evaluation. If I receive a compound, a compound condition type, and inside there is, for example, a simple signature that uses ED25519, and I'm not able to evaluate ED25519 signatures, I should reject this upfront. I shouldn't take that condition, tee up the transaction, and forward it on, because when it comes time to evaluate it and I unpack that compound fulfillment, I'm going to find a ED25519 signature, and then I'm not going to know what to do with it, which, even though the signature is valid, means I'm probably going to roll back that transaction and somebody else isn't, which breaks the protocol. The fulfillment is a little simpler. It has the type indicator and then a payload. The payload's obviously different depending on the type. So that's an example of the ED25519 fulfillment. It's the public key and signature. Sorry, I'm going to go back one slide. The fingerprint here is important to note. So in the condition, what that fingerprint is a unique identifier for the condition. In the example of, for example, that ED25519, that would just be the public key. But for something like a compound type, like the threshold or the prefix type, that would actually be the result of this Merkle circuit of the other condition fingerprints. And I'll explain that in a second as well. Where we see crypto conditions as potentially useful as a drop-in replacement for existing signature schemes, where the condition is the publicly shareable piece, similar to a public key. The signature is the actual fulfillment of that condition. So that would be all of the data required to evaluate whether the fulfillment is valid. And then you can still provide a message. So that could be something contextual. So in our case, for example, you could define a higher level protocol within the interledger protocol that says the message is derived from some sort of transaction data. And what's important there is that the condition can be derived without the message. So the condition is always something that you derive from the public keys of the internal pieces. There's no need for the signatures upfront to do that. We, in this initial version, have defined these 5 types. So there's a pre-image type, which is very basic, effectively a hash lock. What that is that the condition is just the hash and the fulfillment is just the pre-image itself. So the message is completely ignored. So you would use this in use cases where there is no message required. So fulfillment of that condition is simply providing the pre-image. It's a one-off signature effectively. We've defined an RSA and an ED25519 type. So those are the 3 simple types. For RSA, we're using PSS, and we have what are the other parameters? All based on SHA-256. So these types, other than ED25519, all use SHA-256 as the fingerprint hashing algorithm. If you wanted to introduce different hashing algorithm or a larger hash digest size or whatever, you would just introduce a new type. So actually, I've made a mistake here. The name of the types are pre-image SHA-256, RSA SHA-256, ED25519 is just ED25519 because we don't actually hash the public key for the fingerprint. It's already the same size. It's usable as it is. And the same with prefix and threshold. So prefix and threshold are the only compound conditions we've defined so far. I'll go into a bit of detail on what prefix is in a second, but threshold is effectively a set of sub-conditions and a threshold. So what you would do is, let's say for a 2 of 3 signature scheme, you would take, let's say, 3 RSA simple conditions, put them together, and you would come up with and you'd pack them according to the format for a threshold condition, and you would specify 2 as the threshold. Now, when someone provides the fulfillment for that, they would provide 2 fulfillments for 2 of those conditions at least, and then they can just provide the actual condition again for 1 of them. So they only actually have to provide the fulfillment for 2, and when you evaluate that, you evaluate that 2 of the fulfillments are valid, and that is equal to or greater than the threshold. As I mentioned, we use Merkle circuits for the conditions. This is the fingerprint. So basically what that means is you in a threshold condition, you can provide conditions instead of fulfillment. So an unfulfilled condition where you don't need to meet where you have 2 out of the 3, and the result is that you always generate the same fixed size fingerprint, no matter which fulfillments and conditions you have. So you have different combinations of conditions and fulfillments, you get a deterministic algorithm for producing the overall fingerprint, and that's important when you're validating the fulfillment. Final comment, two comments. Max fulfillment length is also something that's provided with the condition, and that's important to ensure when you see a condition that you feel like your system is going to be able to process the fulfillment, that you're not going to receive, masses of very big signatures that maybe in a resource constrained environment would be problematic. I've kind of explained that slide. The same issue. So the last thing is then the prefix conditions. Prefix condition is a compound type, but really all it is wrapping an existing condition with a prefix, so that when you evaluate it, you apply the prefix to the message before you validate the internal signatures. And that's useful for basically namespacing a condition. So you can reuse a PKI pair, for example, when there is no message. So in a context where the message is always empty, you would only be able to use that key pair once. There's some related work here, which are in the slides if anyone's interested in having a look at. None of those met the requirements we had, most specifically the ability to produce this key that is sort of looks the same no matter how complex or simple the underlying signature is going to be, and a bunch of other related work that we've used or referenced that are worth looking at. In terms of implementations, that's where they stand. There's Python, JavaScript, Go, and Java implementations. Java and Go are not entirely feature complete. In terms of possible future extensions, obviously we'd like to support a bunch of additional signature algorithms or even digest algorithms. So we only have a few at the moment, and those met the requirements we have. And these are the open questions that we still need to answer. So the first one, we've proposed a change to what's there, but I'd be interested to hear what people think of that. Also, in terms of elliptic curve, we've gone with ED25519. Is that a good or bad decision, or should we just do both? Then when we were here, when we had IETF in Berlin, we had a lot of comments around CBOR and whether we should rather use CBOR as our encoding format rather than ASN1 and OER. So I'd be interested to hear that. And then whether this has all the right ingredients to potentially be a standards track work at IETF. And that is it. Sorry, that is the proposed new binary encoding. As you can see, type and subtypes with fingerprint and fulfillment length. And that is it. There is a mailing list, an interledger mailing list, which we're using at IETF. Anything else?
Thank you, Adrian. Any questions? Okay. Oh, okay. You.
Hi, Sean Turner. Hey, I love the way your presentation style, by the way. It's like 35 slides with just not a wall of words. I guess I went to the BOF last time, and I guess I remember there was the question about the encoding scheme and whether it should go CBOR. Your statement about it being a drop-in kind of isn't really true, though, right? Since everybody else uses DER. So the different thing, and it's kind of like, I don't know, maybe the encoding choice might be a barrier of entry. I don't know if you've had any kind of experience with changing it. Like, does it actually affected people picking it up, or do you think that the code you've got developed is good enough to get it out there and get going?
Okay, so the closest experience we have is I've been working on the Java implementation, and I've tried to emulate the JCE, the crypto extensions sort of style. It's doable. When I say drop-in replacement, I don't really mean, sort of data for data, but more that the API is the same. You have a public piece, you have a message, you have a signature. So it's described as ASN1 now. We could just switch to saying, okay, canonical encoding is DER, I guess. If that's advice that sort of everyone thinks.
I'm a reformed ASN1 fanboy, so I'm not suggesting that. I'm just saying.
Okay.
Thanks.
Cool. Hey, Wendy.
Relaying for Stephen Farrell from the Jabber Room, who wondered, could you say a bit more about what's changed since the BOF in Berlin?
Wow. What has changed since the BOF in Berlin? More implementation experience. I can't off the top of my head, to be honest. In terms of the spec itself, we revved the spec to make it more clear, but I don't think much has changed in terms of the technical detail. So between 00 and 01, it's mostly textual stuff around how it works and some bugs, but that's it.
Hi, do we say names here? Rich Sauls. So if I understand, what you've got is a thin sort of algebraic tree layer around existing signatures, and you add a new type, which is a digest, which can be anyone you want as long as it's the color black, right? But you turn all of those signature types into octet strings. I'm wondering, since most of the signature types are often pre-identified, why don't you just come up with an algebraic tree to map your language and then just use the signatures natively?
So I guess we needed a uniform format that was quite simple. So it's defined as an octet string there. What that string is, I don't know if I had that there. So when you compute the condition, you basically, depending on the type, it's going to be different things. So it's a hash of, in the RSA case, of the key, public key. In the pre-image case, it's the hash of the pre-image. In the case of a threshold, it's the hash of the concatenation of the subconditions. So there's different inputs each time. That's one of the reasons.
Well, unions are kind of a solved problem already in the ASN1 thing. I just
we can go. I mean, I would like to understand in more detail what that would look like, what you're proposing.
Any defined by? I'm not sure I'm actually proposing anything. But in terms of getting use and deployment in existing libraries, the fact that you take a well-known complicated data structure that has had, like an RSA signature, that we've had lots of problems with getting right? PKCS1 versus PSS, and then you just turn it into a octet string.
So we've done that by saying,
I know
all those parameters are hard coded. There's a standard, there's a set for this type. This is the exponent you must use, and this is the masking algorithm in that.
So we have this phrase in the IETF, crypto agility. So don't.
If you want to use different variations, then you just define a different type number.
Yeah, but we've already got all of that in using the types natively. So you may want to. I suggest you reconsider. That's all.
I hear what you're saying. That the challenge is the upfront evaluation and saying.
That's your shim. That's your wrapper layer.
The envelope, right?
That's your wrapper layer that you put around the existing legacy style signatures.
But they're different for different signature schemes.
Yep.
And we need something uniform. That's kind of the challenge.
No.
Think of it as it's like an envelope with a number that says inside here is an RSA signature with these parameters, and if it's a different number, it's an RSA signature with these parameters. And so it's kind of enumerating all those combinations.
I don't understand why you're seeing that as a big deal. It's
No,
not.
I'm not. I'm asking why. I'm not sure if I understand what the
So
ask
it's
is.
a union, right? It can be one of this signature, this type, this type, this type, or this type. And there were constructs in almost any data definition language you want to use. Let's say ASN1, any defined by, where you have an identifier at the beginning that's a short prefixed OID, and then it's an RSA signature, or it's an EDDSA signature, or it's a Goldilocks 448 signature, whatever it is. And I don't think the way to limit the choices, I think that's got two problems. One, it takes these data sections and your layer completely hides what the values are, which I think is bad as an implementation and bad for security analysis. And then two, it actually limits you. Now, maybe you can define a profile that says we only want these kinds of things. But I just think taking the long history of signatures.
So I'm just trying to understand the suggestion. Is the suggestion to use OIDs?
The suggestion is whatever you need to do to turn the signature and the key value into being the actual existing defined ASN1 structures for those signatures and those key values. And then you figure out what you have to do to enable that. That's the suggestion. And there's a number of techniques depending on what you want to use.
I'm going to ask you for some help understanding that in more detail.
Okay.
All right.
But that's
Thank you.
fine.
Thank you for your
Thanks.
talk. All right. So next up, we'll have Alan DeCock for the DHCP 8021X. I didn't see Alan though.
Is there an Alan in the house?
Wendy, can you just ask Stephen, is there someone else speaking for Alan that I'm not aware of? Maybe he was aware of? I don't think I've seen Alan. Yeah, so I don't even see him in the room. Yeah. I thought he was remote, but he wasn't.
Should we reorder and come back to him?
Sure, we could do that. So next we have Fernando Gant for numeric IDs.
And I guess if anyone has a way to reach Alan on, Jabber or similar.
Thank you. My network isn't working still, so.
Yep.
Yes. Yep. Thank you.
So my name is Fernando Gont, and I'll be presenting a couple of ideas that we had presented at the IETF meeting in Buenos Aires about the security and privacy implications of transient numeric identifiers using network protocols. As a brief introduction, what are these numeric identifiers? They are data objects that are used in different protocol specifications to uniquely distinguish among objects. What we tried to do as a kind of background here is we looked at problems that we use, that we found at identifiers in different protocols from different layers. And we tried to come up with a solution, like a general solution to avoid problems in the future for these identifiers and others. So while looking at numeric identifiers, we found that usually they have specific properties that are required from an interoperability point of view. In some cases, it's uniqueness. There are other identifiers that are required to be monotonically increasing. There are others that are required to be stable within some sort of context. And associated with those identifiers, there's like a failure severity, or put another way, what can go wrong or how wrong things can go if you fail to actually comply with those properties. What are the issues associated with these numeric identifiers? If you look back into history of different identifiers in different protocols, we got them wrong for different kinds of identifiers in different protocols. There have been issues with predictable TCP initial sequence numbers, issues with predictable ephemeral port numbers, issues with predictable IPv6 interface identifiers, same thing with fragment identifiers, same thing with DNS transaction IDs. So while looking at all these issues, which if you look back into history, this dates back to that paper published by Morris in the early 80s, right? And all of these issues have been repeated for different kind of identifiers in different protocols. Problem is, essentially the same, but unfortunately, different, specifications of different protocols, essentially failing in the same way. In some cases, what you find is that, well, first of all, it took so many years to actually fix the problem. Just to give you an idea, with TCP initial sequence number, the paper by Morris was in the early 80s, and we got to formally fix this a few years ago when it comes to ISNs. So the idea is to, reduce the amount of time that it takes to get this fixed, and also to prevent other identifiers in other protocols to, suffer from the same problems. So when trying to analyze, why we have these kind of problems, we came up with, 3 different reasons for which, a number of protocols have these problems. One of them is that a number of protocol specifications under-specify their identifiers. So they don't require like any properties, like, this should be unpredictable. That's the case, or that was the case with DNS transaction IDs or the ephemeral port numbers in transport protocols. There are other specifications that over-specify the identifiers, meaning that, for example, for the fragment ID, the specification suggests that it has to be a global counter. So is the spec suggesting that you end up with predictable numbers? And obviously there are other cases in which, the spec does the right thing, but the implementation just, failed to do what it's supposed to do. So what have we been doing in this area? at the IETF meeting in Buenos Aires, we presented the document that is in the first bullet. That document was meant to do like a bunch of things at the same time. On one hand, it was providing the timeline for what happened with different identifiers, and I think that what we tried to show with those sample timelines, first of all, was how long it took to actually get the problems fixed. In some cases, it was something like 20 years, in others around 30 years. It was also interesting to see how a problem found in one protocol was extremely similar to a problem found in a different protocol, but things fixed in one protocol didn't affect at all what happened in a different protocol. Okay, so for example, we fixed how the IDs are generated for fragment identifiers in IPv4, but that didn't affect how we generated the fragment IDs in IPv6. Okay. Then what we try to do is, not just try to spot, let's say, identifiers in protocols that had these problems, but actually try to do something to prevent the same thing from happening in the future. So what we did was we tried to do an analysis of the type of identifiers that are needed, and we came up with a number of categories, so that if you are specifying a new protocol, it's quite likely that you are using a type of identifier that has been used for a different protocol, so you don't need to rethink the way in which you generate those identifiers. And then in that document, we also at the time were proposing to update the RFC, I don't remember what, 3552 bis, with recommendations on how to, with recommendations or additional recommendations on what to do in security considerations when you were writing a new document. That is like doing a specific analysis of the IDs that you were using. Since the IETF meeting in Buenos Aires, we split that original document upon request of a number of people. So we came up with these 3 documents. The first one is the document that has the timeline for different identifiers. In the current version of the IDE, we have included timelines for IPv6 interface IDs, TCP initial second numbers, fragmentation IDs, and we are working to add a few more, like ephemeral port numbers, NFS file handles, and DNS transaction IDs. Okay. This was in response to some folks from the working group that mentioned that it would be great if we could have examples of, these kind of problems, but in different layers. So we have, examples from the transport layer, examples from the internet layer, but for example, we were missing examples from the application layer. And that's, for example, what the NFS file handles is supposed to address. The second document on numeric IDs generation, that's the document that tries to provide advice as opposed to be just, merely informative. We added a lot of clarifications thanks to the feedback that we got from a number of people. And what we are working right now is to obviously improve the current ID, but also to provide a more elaborate discussion on the reuse of identifiers in different layers. In the current version of the ID, this one, we do have some discussion about that, but only when it comes to the reuse of MAC addresses in IPv6 interface identifiers. But there are other examples when it comes to the reuse of identifiers in different layers. This last document has been dropped. I mean, we are mentioning it here because, well, it was one of the spin-off documents from the original one, but we dropped that one. The plan is to discuss the paragraph or so that there was in that text to be considered for adding for 3552 bis. I guess that's part of the possible updates to 3552 bis. So that's basically the update on what we did. I don't know if there are any questions. Yes.
Hi, Juan Carlos Zúñiga. Thanks. Could you go back one slide, please, Fernando?
Yes.
Yes. So, thanks. I think this the split is helping understand. You've done a lot of very good work, and it was hard to digest when it was all put together. I think that's a very good step. I've also heard a number of comments about different pieces of the document. My comment goes about the actual split that you've done.
Uh-huh.
I think that especially regarding the first two parts, there's mainly two big pieces of information. One is educational and information, and you've digested and analyzed, and I think that is great. The second one is on the advice and the proposed solutions.
Uh-huh.
So to me, the split is would be best if we kept that split in that way, because then it's you have one document that is actually informing, educating people, and doing very good work on all this analysis that you've done, and then there's another document that we can discuss separately on what to do. To me, the categorization of numeric IDs is probably belonging to the educational part or the informative part. I know it's not an easy split. It's not just like copy this section and put it there, because there's of course editorial work to be done. But I think that will be a cleaner separation of the work and an easier way for people to digest and use it. For instance, one piece here that we can take on different protocols and even beyond IETF, let's say in IEEE. And the other one we can discuss specifically, okay, what are the advice on how to use these identifiers and algorithms and stuff.
Okay, so comment into that. First of all, if you are willing to help us, you're welcome. So that's the first thing. And the other thing is that in our document, we do two things. So in this document in the middle, right? So on one hand, we define different categories, based on the requirements and the failure severity. I think that's something that, based on what you're saying, you'd probably, keep here. What we also have in that document is when it comes to the sample identifiers that, we are analyzing, we also mention in which category each of those fall, okay? So that's probably a part that we could, let's say, move out of this document. But when it comes to the definition of the categories, the reason for which we kept it here is that, let's say that you are specifying a new protocol and you say, okay, well, my requirements is that I need some sort of ID, for example, in which the ID needs to be unique, but things fail really bad if I don't get that uniqueness. So it's like if there's a collision of IDs, right? So you need to, figure out which is the category for the ID that you need, so that you know which of the algorithms you should use. That's essentially the idea. But I agree that this document has two things. So on one hand, it does specify the categories, which is something that, yes, I probably keep it here. The other thing is that probably for this document, we don't really need to say, well, in which category does the fragment ID fall, or in which category does this other ID fall. We provide that as examples, for people that read the document to see, okay, well, now I understand. So the fragment ID has these properties, so that's why it falls into this category, and that's why I should use this algorithm. But this was like a first step into splitting the document. So it's not that, we want to stick to this structure of the document. It was a first step. So I'm happy to work with you further to improve this. And if there's stuff that needs to be taken out from one document and moved to another, that's perfectly fine.
Okay, so I'll take a look and I'll give you comments there.
Perfect.
Thank you.
Paul Hoffman, I have still a fairly significant issue with the generation document, which is that you use random parent throughout as a way of doing this. Many of the things that you're talking about actually need to be running at extremely high speed. The random function on different operating systems, different languages, has a widely varying profile of speeds. The amount of randomness that you need might be more or less, such like that. And unfortunately, historically, we've done a really bad job here in the IETF of telling operating system vendors or operating system developers, language developers about less need for high quality random. Don Eastlake has an FNV draft that still hasn't finished. Don, I'm kicking you a bit on that one, as I do once a year. But there are much more efficient ways of getting randomness and mixing, and really all you need is the mixing function, not the mashing function for this. But just saying, just do random here, I think is not the answer for a lot of these things, because if you are having to say generate IPv4 header things very, very rapidly, and you just are pulling in your normal random function, you could be going way slower on that one thing. It might even be very important that you do that, but there are fast random or fast mixers and slow mixers. So I think that you need to discuss that a lot more, because you can't just assume random is random from a speed point of view. Some of them might be better or worse, let's not worry about that. But just from a speed point of view, and that's, I think, critical to having people use this.
So just to double check if I got your comment right. So your concern is that when we use random in the document, that might be mapped to the function that the OS is using, which
yeah, you have that in your pseudocode.
Okay, so what if we were either to change the name of the function that we use there and then specify what we mean with that function and, you know, provide a more thorough discussion of what goes on inside?
You can do that, but the discussion has to be about speed. I mean, some of it has to be about, is it a good random function? But, you know, it's 2016. Most of them are at least okay for what you need. But speed is critical here, because if somebody looks at this, implements it, says, oh, I need to start putting random in here, and all of a sudden the performance of generating new packets goes to hell, they're just going to pull it out. I think what you need is a discussion of saying, if you can't use your, you know, the easiest random number generator you have, come up with a better one and have some discussions. And we don't, unfortunately, we don't have advice for them on that. We could, but we don't.
Well, I guess, I mean, I'm thinking out loud, I guess. I mean, I agree with what you're saying. I think that as a kind of advice, what we could do is, you know, to come up with examples of what some operating systems are doing. For example, OpenBSD.
Yep.
I don't know if that would completely address your comment, but I think it would be like, you know,
it would alert the reader better.
Okay.
Like, for example, if you just take a good one and a bad one and put them together and say, this similar looking call had these very different properties that affect you, I think that that would at least alert the reader to say, oh, I still need randomness, but maybe I can't just do the simple way.
Fair enough.
Great, thanks.
Thanks.
One is Jabber Relay for Stephen Farrell, who asks, why just numeric identifiers? Why not include others?
We started with numeric identifiers. I mean, because for most of the protocols that we were analyzing, I guess below the app layer, they were numeric. I guess I mean, there are other identifiers. You could say that, you know, an email address is an identifier, but yeah, we could expand on that. Yes.
Thanks. And also a note for the room that Alan thinks he's ready for remote participation when this is done.
Great. Yes, I see him in the Meet Echo. Thank you. Any other questions? All right. Thank you, Fernando.
Thanks.
So next up is Alan DeCock on DHCP 8021X, and let's see how this works.
And Alan will need to tell me when he wants slides flipped.
So if this doesn't work, I also have Alan on Skype, and we have a backup channel here.
Ah, very good.
Good luck.
Thank you. Yes. Yeah, Alan, can you request so that I see you in the queue, and then I can allow the speaker in the queue by pressing this red button, which looks super tempting, so I'd like to do it. All right, he's in the queue. I press the magic red button. There he is.
So get the slides up. Let me just see 1 second where
I can't see the screen or where the slides are. Anyways, the document here talks about 802.1x and DHCP and came out as a result of some discussions in SAG. If we can go to the next slide. So the second slide is the problem that DHCP is largely entirely unsecured and there's no ties between 802.1x and DHCP. So in situations where we have 802.1x, we have all this nice crypto, TLS, whatever, to secure the authentication, to prove who either end of the channel is, and once that's done, we have DHCP, which does not leverage any of that. This is probably an issue. Now, as people have pointed out, the network switches can enforce some DHCP security, but the client has no idea as to whether or not this is actually happening. So if we go to the next slide, the proposal is to create a DHCP signing key from the 802.1x master session key, and then use that to sign DHCP packets. So if we go to the next slide, how does it work? The Radius server generates the keys, and the DHCP server uses them to verify and sign the packets. The client uses them to sign its packets. This is not entirely accurate. Based on some discussions we had in Radex about this yesterday, there's some updated issues. So if we go to the next slide about exchanging keys, the keys need to be exchanged securely via implementation defined methods. So at some level, the DHCP server needs to know what those keys are. So when it gets packets, it can verify the signature. And it either needs to request those keys from the Radius server, or the Radius server needs to push those keys to the DHCP server. How that's done is a bit outside the scope of this proposal. So if we go to the next slide, what does it mean for this signing to happen? At the minimum, it means that the DHCP and AAA servers can talk to each other, and they're run by people who talk to each other. Whether or not this means that the DHCP server is trusted, is secure, I don't know. That's something for ongoing discussion. If we go to the next slide, we have problems. There's a lot of details not worked out. This is just sort of a stab in the dark with an idea. DHCP does not really provide for capability negotiation. So the client just signs the keys and the server, signs the packets, and the server just sees that or not and signs the replies or not. 802.1x doesn't really provide for capability negotiation, so there's no way to signal that, hey, I would like my DHCP packets after this to be signed, and I can do that. So this is all just sort of do things and hope the other end notices. So if we go to the next slide, questions. Is this a good idea? Does it help security? Does it not hurt security? Can it be implemented? Will people implement it? These are all open. The one thing which came out of the presentation of this in Radex yesterday was that Stefan, among other people, pointed out that this really has to be done. These keys have to be derived from the EAP MSK, which goes in the Radius packets to the access point. And one of the reasons for this is that the Radius server may not be co-located with a DHCP server, in that the DHCP server is local and the Radius server may be remote, and you may end up proxying over half the internet. And the only way that you can do any kind of key derivation and have it be secure and sane is base it on the MSK, which is sent to the access point. This does have some positive benefits that the access point can now verify the signatures itself if it needs to, or sign the packets. So that's sort of a stab in the dark, and the question as to whether or not this is useful, interesting, problematic, or something is, I guess, open for discussion. So questions?
Bob Moskowitz, HG Consulting. Interesting, and my first reaction to this is, should this be done directly in 8021X as potentially adding a new 8021X payload, let's call it DHCP OL, and then be able to directly use the keying within the 8021X for protecting this, not just over the Wi-Fi use of 8021X, but also Zigbee, Wison's use of 8021X, and Ethernet's use of 8021X, and then have a generic class of across media type implementations. Of course, that does mean a PAR in 8021, which has its own joys, but I might think it may be better to take this directly to the people who own the media and look at security at that point.
Quite possibly. The benefit about the current stab in the dark, as it were, is it doesn't really require integration or coordination with anyone else, right? The access point has this MSK and can derive a DHCP signing key. The supplicant can derive a DHCP signing key. RFC 3118 has been around for a while, whether or not anyone implements it. And so it may be good to get some input from the IEEE on this, but I don't know that that's required. But I'd leave it to Bob to know more as to exactly what the best approach forward there.
I don't see Dorothy Stanley here, who can comment more on the 802.11 MLME and what that would mean there. And the first body here that I would turn to would be Dorothy. There may be somebody else here who at this meeting could comment on that. I think it would still be a change to .11, and like I said, you then leave Zigbee and Ethernet out in the code in that way.
Okay.
All right. Thank you, Alan.
Thanks.
And the last talk we have is the effect of ubiquitous encryption. Is Al Morton in the room? No. Okay. So I can handle this on the co-editor. But I'll step down. Do it.
You want a clicky thing?
Oh, it's only.
I can just like put
All right,
3 slides. I
thank
can
you.
flip them.
Next slide, please. All right, so let's see. The memo is intended to be a collection of things that are broken by encryption, and it's meant just to document. Oh, Al is here, so I'll continue, and then Al can pick up because that was the plan. So it's just meant to be a collection of things that were broken by encryption to document what was broken and what the specific function is that you're trying to achieve by doing that, what data you need. It's not meant to fix any of these problems. Obviously, some of them won't be able to, you won't be able to do some of the functions documented, but the hope is that by documenting them, we could find other ways through creative means to solve the same problems and reach the same goals. So Al, if you want to.
Thanks, Kathleen. Sorry for being late. They just ended a few minutes late next door. So I guess that was a good start. And why don't we move to the next slide? All right. So in this draft, we put on some new material. Really, it's been an interesting exercise because we didn't try to make this exhaustive, but we did end up with a really long list. And one of the things you can appreciate about this is that it took a long time for people to come to grips with the technology that they were using and to find ways to measure it and to meet the regulations that they were up against and so forth. And so there's a lot of things now we're beginning a time of evolution of those capabilities. And it's going to take some time for that to happen as well. So in the draft, we have more recognition of the troubleshooting aspect. You'll see that, and that's about assuring performance and availability of the services. And that's where we're kind of in a security and performance measurement. That's the side of the house I work in. That's the thing we have in common. Steve Bellevin always used to tell me that security people are good performance measurement people too, because they know they can't introduce a new security technology that makes performance stink. And that way people won't use it. So I think we understand both sides of that. So let's see here. The application service providers, that's a new section contributed by one of our folks. And also in section 4.1, the monitoring needs of the enterprise. So these are our sections where we've really expanded the understanding of what people are doing today. And there was a lot of editorial cleanup to do, but that's hopefully done now. And so the next step we're thinking about is the IETF last call. But we're going to have some time for comments. Of course, there's time right now for comments. So thanks.
Thank you. And if anyone wants to take a look at the draft and contribute more text, there is still time for that. So if we've missed something, let's catch it and get it done. Thanks, Al. Any questions? Yep, go ahead.
Hi, Darren Pettis with US Bank. Thanks for writing that paper, Al. It was great to see it laid out so professionally. Some of the challenges, and Kathleen, challenges that we face today. We're kind of stuck in a bind between wanting to move forward with the encryption that they've laid out so well in TLS 1.3 and meeting our regulatory needs. So still looking for solutions on how to move forward there, even if it's in an interim manner until we get to a permanent solution. Appreciate any input. Thank you.
Thank you.
Hi, Mike Ackerman with Blue Cross. Echoing Darren's thanks, you guys did a wonderful job here, and it's starting to get information out there that us clueless enterprises badly need. So thank you very much. I have a question or maybe a plea for help that maybe is out of sequence here, but let me ask it anyway. In the event that we do need help, that we actually realize some of this stuff is coming at us, how best to get it's really two questions. How best to get that information out to all of us enterprises that aren't here, which is most of us, and then what to do about it in terms of crafting solutions.
Okay, so there's the IETF announce list. You can follow the publication of when drafts are published. Yes, we have a lot of working groups, but the IETF announce list might be a good place to start. You know, some of us give talks at industry forums. I mean, it's difficult. The IETF, we're made up of individual participants, right? So it's driven by what individuals, you know, have time to do, and, you know, in terms of going out and talking in other forums. I know Stephen and I, and probably the TLS chairs and people working on TLS, have been invited to speak at various places. I know one thing I tried doing was I had recorded a presentation through EMC on the crypto trends. So there's a recorded one out there, and that was, gosh, at least a year ago that was done. And this was noted within that presentation. So we've all made some efforts. Stephen's talked a bunch in a number of forums on pervasive monitoring and related drafts to that. But that was, these were on invited bases for both of us and the number of talks and things we've done. If you have suggestions or if there's other places where, we should be speaking, it's not just the ADs, but any of the participants
Yeah,
who are experts in areas can help.
That we could leverage the IETF or maybe work within the constructs of the IETF to craft solutions rather than us being left to our own devices.
Oh,
That would be
solutions.
very dangerous. Yeah, I guess my question was two-part. Get the information out there so we realize this is coming. I now do because of this week, but I'm in a rarity in terms of enterprises. I will go back and tell everyone that'll listen to me, which isn't very many, but and try to get the word out that way. But there's got to be a more effective mechanism, and I hope that's through the IETF. So that's the information dissemination. That's one. And two, the more important thing to me is how do we arrive at solutions? And I'd love to do that through the IETF again, not out on our own or trying to pressure vendors into doing things, to come up with standard solutions that we can all use and leverage. So.
Right. So documenting the problem is one way to have it recognized as a problem so that other smart people who might come up with creative solutions can see that that's a problem to be solved, right? So maybe academics seeing this, the documented problem sets might be of help.
Paul Hoffman,
And-
just for the people in the room who aren't hearing what he means by solutions, he means not encrypting or encrypting in a way where, and I just want to be really clear because your document is wonderful in the sense that it lists the problems and leaves them as problems because in fact, those problems are in fact solutions for many of us in this room. Ubiquitous encryption is something that we've been working on purposefully for decades. So I hope that you don't take those comments as something where you should be expanding your document into solutions. I'm not with your co-chair. I'm certainly not worried that you wouldn't have noticed that. But I believe that asking the IETF for solutions to a problem, which is I have a regulatory thing, my boss wants to be able to snoop at traffic, I'm an ISP and I think I can monetize traffic if I could see it more and such like that. I don't believe that's the scope of the IETF. So maybe as you are going out and describing the problems to people, you can also describe the scope and the tenor of the IETF.
Okay, so in terms of solutions, I do think that there's more than the ones that we find objectionable, right? So the ones that we've agreed are objectionable. Right. And I'm sure many people agree that if we increase logging, then some of the troubleshooting functions that have been complained about would help solve the problem so that you will not need to peer into sessions, right? Like a wrong password was an example given, and that really should just be done by logging. So vendors, anyone in the room who works for a vendor, I know I've made a concerted effort within my own company to help state the importance of this. And a lot of the engineers who worked on things like IPsec encryption for our specific use cases, they've made a point of increasing, logging and being able to do the networking, troubleshooting, administration responsibilities. So I think that's the responsibility of every vendor to go back and do that. I know one of the complaints, because I've raised this previously, on this specific question, is that it's impossible to go back to every vendor. However, we have a lot represented here, so we could each go back and try to do a good job of that. Then in our drafts, we can also make a concerted effort to make sure there are notes explicitly stating that things are logged better. And there may be other solutions, right? So if folks who are creative could take a look at the ubiquitous encryption draft and start thinking up other ways besides breaking encryption. Are there endpoint things that we can do? Are there logging things that we can do? Are there other solutions that we haven't thought of that would not be objectionable?
And I can say I'm going to walk away happy now because this is the type of dialogue that I would love to see where we're talking about solutions. My first comment, though, is extended logging will be great. It will not be a panacea, though. But at least we're starting to talk about what potential solutions are. And one of them is not to abolish encryption. I'm from healthcare. We need more of it, but we need to be able to manage it too.
Right. If we could ever get to a point of more secure endpoints, like through SACM and system hygiene and through encrypted channels, then some of these things should really start to fall away once we get to a better security state.
A recommendation is maybe a non-working group mailing list inside the IETF, and then reach out to the various trade groups and the rest of it to get their participation and asking their questions. And with IETFers, then pointing them to things of interest and then go from there. But if the gentleman from Blue Cross and the banking person were to step forward and make and request a non-working group mailing list, that may be one way that you can do it, Kathleen.
Sure. Yes. Thank you. That's a good idea. Is it Wendy up next?
Just standing here in case the driver scrubs.
Oh, okay, Nalini.
Oh, sure. Okay. Yeah, Nalini Elkins. I just kind of wanted to play out some of these ideas. I wonder if that would be appropriate because I just, you guys just did such a great job in describing so many of the problems in such detail. I really want to thank you guys, for all the hard work. And, it's I'm just kind of thinking out loud too, I guess. Really, I would just love to play out some of these ideas about logging. I wonder if that would be appropriate. It's like maybe on this email list is like take some problems and some sample topographic, some network topography, something like that, and play them out. And I wonder if that would be an interesting draft to do maybe in SAG for next time, is if I go back together, maybe, and whoever would like to, as I say, it's like now I hear that idea, I'm like, oh, let me see what happens with a real problem, like what needs to be logged to where, you know what I mean? Because definitely some of the work that we're doing for PDM, the embedded performance and diagnostic metrics in IPv6, is going to do a number of things for response time, the server times that you need. So if you need that, then I think we probably have an answer. Plus, I hope they can revive some of that, because I was just really looking forward to some more embedded diagnostics and stuff. Diagnostics is, I love diagnostics. And so I would love to see, like how do we do this? But does that make sense to you? If we can does that make sense to have to play out some of these things in reality? Because I'd love to see follow-ons. You guys have opened up such an area. I'd love to see follow-ons. Am I babbling? Yes.
Nalini, thanks for your contribution to the draft.
Thanks, Al.
Now I have a relay from Stephen Farrell, who wanted to say, not sure I agree with Bob that this was all about TLS. We have the new work mailing list already, and I'm opposing a mailing list for this one right now.
Hi, Daniel Kahn-Gilmore from the ACLU. So I wanted to push back on Paul a little bit and say that I'm not sure that I hope that people don't frame the problems that are described in this document as the fact of encryption. If the problems are being framed as the fact of encryption, then it's sort of game over and we're not going to have a very productive discussion. If the problems are framed in the sense of we have these operational needs, then we can talk about other ways to solve these problems without breaking the crypto. So I think it's important to make sure that we approach it from that viewpoint. The reason that engineers in this room are pushing for crypto, there's a bunch of good reasons for it. We can go over them again if we want to review the pervasive monitoring draft and other pieces. But as long as we make sure that the problems are not stated as things are encrypted, if it's like, as we've said, we have to, debug failed passwords, then problems like what Kathleen has outlined are the kinds of solutions that people can point you to without breaking some of the benefits of actually getting your network traffic fully encrypted.
Yeah, thank you. We were very careful about the wording to bring both sides of this together.
Steve Fenter. I want to echo Mike's earlier comment that when encryption is added in a particular environment, that solutions need to also be added at the same time for anything that breaks. And if there are non-decryption ways to fix problems, that's great. But if the non-decryption ways are partial solutions, that needs to be acknowledged also, that we don't have an adequate way to fix the thing that's broken. And I think a lot more enterprise input is needed in this organization so that people are aware of what breaks when things are encrypted, so that problems can be dealt with right up front as encryption is being discussed, rather than encryption being put in, things breaking, and then enterprises having to scramble to figure out what to do.
Yeah, that's Darren again. I wanted to thank Daniel. That's a good point. We don't have to have decryption. I mean, we'd rather not. And to be clear, we're only talking about inside the enterprise, not on the internet. Keep everything as is there. So if there's another better solution, we'd love to work with anybody on that. That'd be our preference. The problem is we're kind of stuck in a bind. We really don't have an option to not follow the regulatory bodies and to perform the different security things that are needed to enhance the security within the enterprise. So we're just looking for a way forward. And like Steve said, with TLS 1.3 moving forward, it puts us in a bind. Not now, we know it's a couple of years out, but I think it's a tough technical solution that needs time and work to come together to figure out how we can continue to meet our regulatory requirements before TLS 1.3 is fully adopted, and we're required to adopt it. So that's why we're asking for people to really help with us, because we can't move to TLS 1.3 as it stands today and still meet our regulatory requirements. So that's the bind we're in. So sorry to be continuing to beat this horse. We're just looking for a solution. Appreciate any help. Thank you.
Thank you. So I think that was the last in queue. Just a few notes, just make sure that the problems are documented, and that gives folks an opportunity to recognize that a problem will result from this, and then hopefully we can help develop creative solutions that maintain encrypted sessions and what we already have consensus for within the IETF. All right, so I guess now we go to open mic. Thanks, Al.
Welcome. Thank you, everybody.
All right, anything for open mic?
Hi, this is Yavner. I wanted to make one more try to push for the security considerations draft that we're trying to revise, the RFC 35 something.
52.
Thanks. So far, we've had 0 comments on the list. I'll send another mail to the SAG list, hopefully getting some replies. Otherwise, I don't see how you can really proceed with this.
So
I mean, I can just do what I've already done, update references, remove references to TLS 1.0, and not recommend that anymore. But if you want any other changes, we'll need some community input.
Yeah, so how many people are familiar with 3552? I hope. It's an important document. I'm just going to add on to Yoav's plea. It's used by other areas quite a bit to formulate their security consideration sections. So those of you who do SecDear reviews, you might have a little less defined if this is more robust and gets at all the points that we would like people to cover in their security consideration sections. It's an old document. I know Stephen and I had provided comments on our initial review. We both thought it was important to do this revision. I know other people thought it was important to do this revision. I'm sure many of you would have some good comments and feedback, so I'm just adding on to Yoav's plea to add your feedback, read this draft, and contribute your feedback so that we can have better security consideration sections and help guide other groups, especially if you're cross area. Thank you. Anyone else for open mic? All right, I guess this is it. Thanks. Did you think that there was only one session?
It's in the mobile app.
Oh.
And I was just
I was
going
like, where is Jeff Hodges? And then Warren stepped up, so.